So this is a quick video to talk through the differences between factoring a quadratic trinomial using what's called grouping or factoring the same exact quadratic trinomial using the box method. And we're specifically looking now at the trinomials that have that leading coefficient that we call a, where a is going to be greater than 1. So I'm going to start with the grouping method. And both of these methods actually start with taking the a value and the c value and multiplying them. So you're just going to think to yourself, okay, 8 times negative 3 is negative 24. And then you want to find two numbers that multiply to negative 24 and add to negative 2. And those two numbers in this case would be negative 6 and positive 4. And you're going to put x's with the negative 6 and the positive 4. And you're going to then replace the whole negative 2x with the minus 6x and the 4x. And it doesn't matter what order, you'll get the same answer either way. And so now I'm going to rewrite 8x squared, this time minus 6x plus 4x, and then bring down the minus 3. And then I'm going to do grouping, which says that you want to take two terms at a time. So I'll start with the 8x minus 6x, and you're going to find the GCF of each of the two terms. And so here the GCF of 8x squared and 6x is 2x. And then what's left inside the parentheses is 4x minus 3. And then the ones that I underlined in light blue, 4x and minus 3 have no common factor, but you have to write a common factor. So if there is none, you want to write 1. And you also want to look at the sign that's right here, that's a plus sign. If it were minus, you would use negative 1. We're going to say plus 1 times, and then keep that 4x minus 3. And if you've done this correctly, then what's inside the parentheses in both of these situations, or both of these GCF computations, should be exactly the same. Then you take whatever it was that's the GCF, so in this case the 2x and the 1, and that's going to be one of your binomials, 2x plus 1, and your other binomial is 4x minus 3. And so that's going to be using the grouping method to factor those two, that trinomial there. I'm going to do the same using the box method, and the box method starts the same way. So I'm not going to go through that again, but you start by looking at your first and last term, the 8 and the negative 3, multiply them, get the negative 24, and then find two numbers that multiply to negative 24 and add to negative 2. And this time, instead of rewriting them as an algebraic expression, I'm going to put them into a box. And so here's how the box works. I'm going to draw a 2 by 2 box. And I'm going to put the 8x squared, or the x squared term, always in the top left corner. And the number term, meaning the last term on the end here, that number term is going to go in the bottom right corner. And then you're going to go back and get those two terms that you decided on in the previous step, minus 6x and 4x, and you're going to put those in the other two boxes, and it doesn't matter which goes where. Once you've got your box set up, then you're going to do 4 GCFs. You're going to do 2 GCFs going horizontally, and you're going to do 2 GCFs going vertically. And so your two horizontal GCFs, look at the 8x squared and the minus 6x. 8x squared and minus 6x have a GCF of 2x. And then I'm going to look at the bottom row, the 4x minus 3. There's no GCF there, so you have to write a 1. And then I'm going to look at the vertical GCFs, and I'm going to look at the 8x squared and the 4x, and your GCF there is 4x. Hope you can see the yellow. Now here's a key that when the first term, either horizontally or vertically, the first term you look at is negative, then the GCF is going to be negative. And so minus 6x and minus 3, the GCF is negative 3. So then I'm going to pull whatever I've written outside of the 2 by 2 box, and that's going to be my answer. So I've got the 4x minus 3 times the 2x plus 1, which of course is the same answer, just in the opposite order from the previous problem. And remember that with multiplication, order doesn't matter.